Even when we were children, the stars intrigued us, excited us, inspired us. We looked into the night sky and we wondered, what's beyond what we see up there? Hi, I'm Marcus Lloyd, and in this series, we will answer some of the questions you may have asked yourself. We'll take a journey together, a journey through the universe. We'll look at ways God's creation is confirmed by science, and we'll see that the heavens described in the Bible are consistent with all we've learned about space. Today we know that there are more stars than grains of sand on this beach, many more. But what else do we know? The stars have a lot to teach us, and they've been sharing their lessons for thousands of years. As humans began to understand the passage of stars across the night sky, they found a connection in the migration of birds and other animals, the food they hunted to survive. They learned when to plant and harvest crops by tracking the movement of the heavens. In time, they even found ways to navigate ships by them. The ancients used the motion of the stars to guide their activities, but they couldn't explain why the stars moved as they did. That part remains a mystery. What could explain it all? The answer has been right here for millennia in our one infallible guide, the Bible. Our universe is so complex, so intricately designed that it seems obvious that a supernatural power would be required to create it. Since the earliest of days, we've looked to the stars to help us find our way. As it says in Genesis, "Then God said, 'Let there be lights in the firmament of the heavens to divide the day from the night, and let them be for signs and seasons and for days and years.'" God designed those celestial lights for us, and they can guide us through space and time. All we have to do is watch their movement across the sky. Come on, we have a grand journey awaiting us. So, let's get started. First, let's get our bearings. It's not hard to do these days. Download an app, point your smartphone at the night sky, and it'll identify stars that are millions of miles away. But for thousands of years, the heavens were a great unknown. But people did notice patterns. When they looked to the sky, everything seemed to move from east to west. It's called diurnal motion.
We see that during the day. The sun rises in the east and it sets in the west, and that's because the Earth is rotating in the opposite direction. Now, this is an important phenomenon because it helps us tell time. We know that the sun is in the east in the morning. It reaches its highest position around noon, and it sets in the west in the evening. And then a similar thing can be used to figure out the time of night with the positions of the constellations for a given time of year.
What we see up there helps us navigate the world down here. As we make our orbit around the sun once a year, the tilt of Earth on its axis causes a change of seasons. So when it's winter in the northern hemisphere, it's summer in the southern hemisphere. The moon, which orbits us as we orbit the sun, also affects our planet. Its gravitational pull causes the daily rise and fall of the tides. Each month, we watch the moon pass through its lunar cycle. 12 of these mark a year. But how do we mark passages of time longer than a year? The answer is there in God's design.
The rotation of the Earth is basically like the second hand on a clock. It measures the fastest movement of time in the night sky, tells us the time of day. Now, the orbit of the moon around the Earth, that tells us the time of month. And then the hour hand would be like the Earth orbiting the sun. Now, for units of time longer than a year, we need more hands on the clock, and that's what planets are. But if you could look at the solar system from above, it would all be very straightforward. The planets would orbit the sun in what appears to be circles in a counterclockwise direction.
The moon is a calendar system, and it helps us to keep track of history. There are certain episodes in the Old Testament, such as in the book of Amos, where an eclipse is mentioned. And we do have eclipse data. They are so predictable. This helps us to date some of the details of the Old and the New Testament. And thinking about the moon and the calendar, the date for Easter each year is actually determined by the moon. There's a complicated formula that goes along with that. It involves a full moon and the first Sunday after the vernal equinox. But how interesting that the date for Easter, this Christian holy day, is set by the created moon.
For thousands of years, astronomers had only their eyes to observe the heavens. There were no telescopes, no spacecraft. They studied how the stars moved through the sky and were able to predict approximately how these objects would appear in the future, but they had no idea why the stars moved. Back in the old days, most people had no idea that the Earth rotated and orbited the sun. You can't feel it happening, so it was natural to assume that the objects in the sky were revolving around the Earth. Ancient astronomers were trying to predict the future positions of planets without understanding the underlying mechanism. We were still early in our journey of discovery. In the 2nd century AD, Claudius Ptolemy, a Greek mathematician and astronomer in Alexandria, invented a model of the solar system.
Ptolemy's model of the solar system was the most accurate that had been developed at the time. He was able to predict the positions of planets and the sun and the moon with unprecedented accuracy, despite the fact that his model was really wrong in terms of its understanding of the nature of the solar system. Ptolemy's model was geocentric, meaning it had the Earth at the stationary center of the solar system with all the planets and the sun and the moon orbiting the Earth.
Ptolemy's model also failed to naturally explain a phenomenon we call retrograde motion.
Retrograde motion is the apparent backwards motion of a planet that occurs when the Earth passes that planet in its orbit. It's a bit like when racers are running on a track